Okay, so welcome back to the second part of our lecture. And this lecture will be all about the statistical analysis that will be used to evaluate and to identify our quality control in the clinical laboratory. Okay? Don't worry, I will not go deeper in all statistical analysis. What I will just discuss in this lecture are the most common and the most important statistical analysis that you should remember in terms of quality control. Now, I will not go deeper in discussing the inferential statistics, which includes the ANOVA and the student t-test. You have done that already in your statistics now. So this time, what we are going to discuss are the statistical analysis that is necessary in the clinical chemistry section. To start with, and I know that you are all aware with these three topics or concepts, we have the measures of the central tendency or the measure of the center. So we have here the mean, the median, and the mode. Now, what is mean? When we said mean, that is most commonly used and that is sometimes referred as the average, or sometimes they call it as the arithmetic mean. So we are just getting the sum of all the values divided by our sample size. For median, that is the the middle value in a set of numbers. And in order to get the median, we have to arrange our values according to magnitude. And lastly, we have mode, which is the most frequently observed in data. Okay, for your information, I will not ask you to compute the mean, the median, the mode using the manual or conventional way that you had in your statistics, no, yung manual kayong calculator doon. Or if you use the SPSS, then you are lucky because you were able to use na the SPSS, the software for statistical analysis. Because when we were in college, when I was in college, no, during our statistics days, we have to use the calculator and we have to compute our statistical analysis manually. No? In this class, we are not going to do that, but instead, we're going to use Microsoft Excel in performing statistical analysis, most especially here, the descriptive analysis or the descriptive statistics. Okay, so for a review, let's just have a review. Example, no? I will show my whiteboard. Yan. So for the review, we have the following is the measurement of glucose performed by MLS 3-5. Okay, performed by MLS 3-5. So we have 4.5, 5.6, 4.5, 4.5, 6.7, 5.8, 5.2, 7.2 rather, 7.3, and 6.7. So again, first thing first is we're going to compute for our mean. Natin mean is the sum of all x's over n, no? Where n is our sample size. Again, mean is the sum of our all x's, o ba't pa yun, maraming x, and divided by the sample size. So the mean will be 4.5 plus 5.6 plus 4.5 plus 6.7 plus 5.8 plus 5.2 plus 7.2 plus 7.3 plus 6.7 divided by 10. So that will be, let's compute. No? So again, we have 4.5. Okay, 4.5 plus 5.6 plus 4.5 plus 4.5 plus 6.7 plus 5.8 plus 5.2 plus 5 5.2 plus 7.2 plus 7.3 plus 6.7 divided by 10, that's gonna be 5.8. So our mean, now mean is sometimes referred as the x bar. No, mean is equals to 5.8. Now how about for median? Sabi natin, we're just going to arrange our median based on its magnitude to get the middle sample. So we have our lowest value is 4.5. So we're just going to arrange it. 4.5. Okay, so we have 3, 4.5, 4.5, 4.5, 4.5. So cancel, cancel para hindi tayo malito. Next is we have 5.2. 5.2. Okay. Next is 5.6. Next is 6.7. We have here 5.8. I know that you are shouting, sir, there's 5.8. 5.2, 5.8, okay, 6.7, 6.7, 7.2, and 7.3. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh my god, we'll have 9. Where's the rest? 1, 2, 3. I know you are laughing at me, but let me look for something na nawawala. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4.5, 4.5, tatlo, eliminate, 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 5.2, yes, here. I saw it na, the 5.6. Okay, so we're going to put the 5.6 here at the middle. Okay, 5.2 and 5.6. 5.2 and 5.6, 5.8. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So since this is an even number, we don't have the middle value. Okay, so we'll count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And our middle value will be 5.6 and 5.8. So to get the median, that will be 5.6 plus 5.8 divided by 2. That will be, okay, 5.6 plus 5.8 divided by 2. That will be 5.7. Okay, so our median is 5.7. Now for the mode, sabi natin, mode is the most frequently occurring data. That is 4.5. Okay, so that's how we're going to solve for it. Ngayon, sir, you have mentioned that you're going to teach us how to use it using the Microsoft Excel. Yeah, I will teach you that once we have our synchronous session so that we will have it all together. Okay, so that is how we are going to compute for our mean, median, and mode. Again, that's just a review because you are going to compute the mean, median, mode using our Excel. Okay, so for the standard deviation, it reflects the variation of the data values around the mean. So the standard deviation is computed as the sum of all x minus the mean squared over n minus 1. N refers to the sample size. So I have here already our x values, no, and our mean, the x minus mean squared is this one. So we have already here, and we are just going to sum this one, no, to get the value of our summation x mean, x minus mean squared. So we are going to compute that. So we have so we have 1.69 plus 0.04 plus 1.69 plus 1.69 plus 0.81 plus 0 plus 0.36 plus 1.96 plus 2.25 plus 0.81. Okay, so that is equals to 11.13. 11.13 minus divided by 9. So 9 become y 9, 10 minus 1. 11.9, 11.3 divided by 9. Okay, and then we get the square root of our answer, and our standard deviation is 1.12. Our mean is, this our mean. Our mean is 5.8. Okay, 5.8. Okay. Next concept is we have the variance. Variance reflects the dispersion around the mean, and simply the variance is s squared. Okay, so variance, if our SD is 1.12, so variance is s squared, so V is equals to 1.12 squared, so V is equals to 1.12 squared is 1.25. 1.25, and SD, CV is SD over mean times 100. So our coefficient of variation is SD 1.12 divided by 5.8 times 100. So our coefficient of variation is 1.12 divided by 5.8 would be times 100 is 19. No, 19.31% ang ating variation. Okay? Now, for our normal distribution curve, no, sabi natin, that is a symmetric distribution of all the mean. Okay? So, for our mean, this is the one that is the middle, no, in the middle, no, in the middle, that is the mean, plus 1 SD, and negative SD, no, negative 2 SD, and positive 2 SD, negative 3 SD, positive 3 SD. So in other words, this is our normal curve, and the normal curve is usually a bell curve or a bell shape. No, this is usually a bell shape, and usually the acid values that fall under positive negative 1 SD is 68.30%. 95.45% is the positive 2 SD, no? Sila yung mga naririyan, that is the positive 2 SD, the positive 1 SD, the positive negative SD, and 99.70% of our value is within that positive or negative 3 SD. Ngayon, I have told you that I'm going to teach you on how are we going to do that? So, babalik po tayo dito. Let's have a whiteboard. Okay, so we have here our whiteboard again. So, we are going to remember our mean. Our mean is 5.8. Okay. So we have for positive SD, negative SD. 1, 5.8 plus 1 is 6.8. 5.8 minus 1 is 4.8. Okay. 5.8 plus 2 is 7.8. 5.8 minus 2.8 is 3.8. 5.8 plus 3 is 8.8. 5.8 minus 3 is 2.8. So this is our positive negative S1 SD. This one. Our positive negative 2 SD. Positive 3 negative 3 SD. So sabi natin, our normal distribution curve is usually a bell curve. And the middle of it, that is the mean. So the positive 1, the positive 2, and the positive 3. Negative 1. Let's remove the line. The negative SD, negative 1 SD, negative 2 SD, negative 3 SD. Ngayon, that is our normal distribution curve. No? A while ago, I have taught you of the Levigenin's chart. So this time, we are going to plot our value in our Levigenin's chart. Levigenin's chart is different from this one because this is our Gaussian curve. No, this is our Gaussian curve. The Gaussian curve is usually a bell shape. I'm going to teach you also on how to make a Gaussian curve in Excel. Okay, so let me show my sample a while ago. Yan. So we have 4.5, 5.6, 4.5, 4.5, 5.6, 7, 5.8, 5.52, 7.2, 7.3, and 6.7. So we are going to make a Levigenin's chart using the following. Okay, imagine this is our mean. And we are going to divide, and we are going to represent our mean with a green line. Okay, that is our mean. Okay, our positive 1 SD. Okay, our positive 1 SD is 6.8. Negative 1 SD is 4.8. So let's present our positive 1 SD as a red line. Okay. Next, Our 2SD is 7.8. Ah, let's make it 2SD. Positive 2S. Negative. Okay. We just write here the 1S. Positive. Positive 1S. Negative 1S. And let's represent our 3S using a purple line. Then, yeah, 3S. Okay, so we're 3. Using this Levi-Jennings chart, we'll be able to take note if there's a shift or a trend or 1S rule, 2S rule in our say value performed by 3-5. Okay, so the number 1 is 4.5. Oh, sige, let's make it. This is 5.8, 6.8, 7.8, 8.8, 4.8, 3.8, 2.8. So the first value is 4.5. So that could be here. Part of it is here. Next is 5.6. So near the mean. 4.5. Yeah, to this one. Another 4.5. 6.7. Okay, 5.8. Oh, we are on the mean. 5.2. Okay, below the mean. 7.2. Oh, so we can say that 7.2 is something here. 7.3 is, sige, this is our 7.3 na lang. And then 6.7. Okay, so if we are going to trace it, that will be like this. Okay, so we can say that we have here a violation of 1S. No? So we have here two values. No? We have here two values outside or below, yeah, outside 1 SD. Okay? 1 results outside 1 SD. So that is 1S, 1 2S, or that since that is 2, we can say that that is 2 2S. No? 1 2S rather. 1, I'm sorry, 1, no, 2 1S. Two values, I'm sorry guys, two values that exceeds the 1S na standard deviation. Okay, so I'm going to give you an exercise on that in our laboratory so that you will be able to figure out how to know if there are something that is not should be in our quality control chart. However, this is generally good result because all our results falls under the 2SD, the positive 2SD, and the negative 2SD. Okay, we have now here what we call diagnostic sensitivity. And when we said diagnostic sensitivity, that is basically the ability of the test to be detected to a given disease or a condition. No, that is a percentage of individuals with a specific disease that a correctly identified or predicted by the test as having the disease. While we have the diagnostic specificity, that's the ability of the test to correctly identify the absence of a given disease or condition. Okay. We also have the predictive values, which is the test utilized the parameters to test sensitivity and specificity as well as the disease prevalence. PPV, or the positive predictive value, the people with a true positive or positive test who have the disease. And the negative predictive value, the percentage of people with negative test results who do not have the disease. Ito po yung mga naririnig yung specificity and sensitivity saan? Sa mga rapid test kits, no? Yung mga CPR nila, yung tinatawag na mayroong specificity and sensitivity of their analysis. Okay? So we have here the sensitivity and specificity. Sensitivity is equals to TP divided by TP plus FP. So that is true positive divided by true positive plus false negative. Specificity is true negative divided by true negative plus false positive. And we have PPV as true positive divided by true positive plus false positive. And NPV is true negative divided by false negative plus true negative. Okay, example natin, wait. Example, true positive daw natin for a certain disorder is 77. False negative is 23. False positive is 25. True negative is 75. So we are going to compute for the sensitivity and specificity of these test results. So let's compute first for the sensitivity. So we said that sensitivity is TP over TP plus Fn. Okay? So what is our TP? True positive is 77. True positive is 77 plus false negative is 75. No? False negative is 23 rather. False negative is 23. Okay? So that will be 77 divided by 100 is equals to 0.77, or simply sensitivity of that is 77%. Now, how about for specificity? Specificity is true negative divided by true negative plus false positive. So we have true negative is 75. 75 plus false positive is 25. So that will be 75 divided by 100. That's gonna be 0.75, or equals to 75%. How about for the positive predictive value? So we have here true positive divided by true positive minus plus rather plus false positive. So that's gonna be our true positive is 77 divided by 77 plus false positive is 25. That's gonna be 77. 77 plus 77 plus 25 is 102. So 77 divided by 102, that's gonna be 0.7549. That is 75.49%. The negative predictive value is equals to Tn over Tn plus Fn. Okay, our true negative is 75 plus 75 divided by 75 plus false negative is 23. Please pasensya na po sa mga manok, no? Alam niyo naman, nasa tabing bahay tayo ng manukan. So 75 plus 23 is 98. So I am in urgent to finish this so that you will not be bothered with the noise of the roaster. So 75 plus 98, that is 0.7653, or simply 76.53%. Okay, so that is what we call the diagnostic efficiency of our test. Okay, so before I end this video, I would like to leave again this quote, or this, not really quote, a provision of the Professional Code of Ethics of Medical Technologists, which is to perform a task with absolute reliability and accuracy. That is true with what we have discussed today. Thank you, future RMTs, and I hope that you learn in this video. God bless you all.